Hello students. In this class, we will be going to learn powers and exponents, a very interesting topic of class 7. But before we start the topic, we have to learn what is a power and what is exponent. You can see in the screen that it is written 5 square. It is pronounced as 5 square, or else we can say it 5 to the power 2. So the number 5 is known as base and 2 that is known as exponent. What is the meaning of 5 square? The meaning of 5 square is 5 occurs for 2 times. So 5 into 5, this is the expanded form, and if we want to evaluate the value will be 5 fives are 25. So instead of saying 5 into 5, we can easily say it 5 square. And the base is 5. So the power will be 2, means the number of occurrence will be the exponent or power. In the screen, there are two more examples. The first example is 2 to the power 5, means 2 is the base number and 5 is exponent or power. As I have said you earlier, that 2 to the power 5 means 2 will be repeated for 5 times and the answer will be 32. So we can express 32 as a base 2, then the power or exponent will be 5. So the value of 2 to the power 5 will be 32. In the next example, you can see that the base is 10 and the exponent is 2. It means 10 is repeating here for 2 times. So we can say it 10 square or 10 to the power 2. And if we are going to solve it, then the answer will be 10 into 10 equals to 100. And so we can express 100 in the form of 10 square. In the previous example, we have discussed the case of positive exponent. Now here, we will be going to discuss that what will happen if the base is a negative integer. You can see in the screen a to the power minus n equals to 1 by a to the power n, and where a is a non-zero integer. So, if the exponent is a negative integer, we have to write down its reciprocal. You can see the example is given at the below. 3 to the power minus 2 means 1 by 3 square. As the power is a negative number, so we have to write down the reciprocal of the integer. 3 is the integer, so we will be going to write down the reciprocal of it, that is 1 by 3, and we have to write down the exponent. So 3 to the power minus 2 means 1 by 3 square. The next example, where at the place of base it is a fraction, or else you can say that it is a rational number. So 2 by 5 whole to the power minus 6 means first we have to write down the reciprocal, as the exponent is negative. So the reciprocal of 2 by 5 we all know it is 5 by 2, and we will not forget about the exponent. So 2 to the power 5, 2 by 5 whole to the power minus 6, it will be 5 by 2 whole to the power 6. Here we will be going to discuss the case of zero exponent. If the power or exponent is 0, then what will happen? Any non-zero number raised to the power 0 is equal to 1. So a to the power 0 equals to 1, and where a is a non-zero integer. So there can be any integer. It can be a positive number, negative number, a rational, positive rational number, or a negative rational number. If the power or exponent is 0, the value will be always 1. It is the most important property, or else you can say law of exponent. You can see some of the examples are given. 8 to the power 0 is 1, 0.36 to the power 0, is 1, minus 67 to the power 0 is 1, minus 1 by 3 to the power 0 is 1. So after observing all the examples, what conclusion we can make? We can make that at the place of the base, any integer, any type of number there can be, we will only look after the exponent. If the exponent is 0, the answer will be 1. And another thing that we have to notice here, that is, if it is 0, 0 to the power 0 is undefined. It is an exceptional case. Now we will be going to learn some laws of exponents. Without them, we are unable to do any type of operations involving exponents. You can see in the screen some laws are written, and at the side the examples are given for your convenience. The first law, that is known as the product law, a to the power m into a to the power n is equals to a to the power m plus n. Before applying the law, we have to understand that if we are multiplying any two numbers whose bases are same, no matter their powers are matching or not, we can multiply them. What we have to do, we have to add the powers. You can see the example which is given at the side. 3 square into 3 to the power 5 is equals to 3 to the power 2 plus 5. Here we can multiply them because the bases are same. So we have to write down the base for one time and the powers will be getting added because we are multiplying them. The same thing will be going to happen in the case of division. Just at the place of addition, there will be subtraction. You can see the example is given 3 to the power 5 by 3 squared. The answer will be 3 to the power 5 minus 2. Again, we have to look after that their bases are same or not. These rules are not applicable if the bases are not same. This happens in the case of law number 1 and law number 2 also. In the case of law number 2, we have to consider the exponent of the numerator at the first always. Here we will be not going to write 3 to the power 2 minus 5. We have to write 3 to the power 5 minus 2. Now I am moving forward to law number 3. A to the power m whole to the power n means you can see that the base is 1 but the power is more than 1. So what we have to do? We will not disturb our base. We have to just find the product of the exponents. You can see the example 3 square whole to the power 5. So I will not disturb my base 3 to the power. We will be going to find the product 2 into 5, 3 to the power 10. Now law number 4, AB whole to the power n. If the base, we can express it as the product of any two number, then the exponent will be applied on the two individual numbers. Like here, 3 into 4 whole square, it means 3 square into 4 square. So 3 into 4, I can write down 12 as 3 into 4 square, and then from 12 square, we will be going to end up it with 3 square into 4 square. At the last but not the least, the law number 5, a by b whole to the power n is a to the power n by b to the power n. It means if the exponent is with any fraction or rational number, then the power will be numerator and the denominator simultaneously. You can see the example 3 by 4 whole square. It means 3 square by 4 square. If you want to solve it, then the answer will be 9 by 16. So this class is up to that much. I will come back with the detailed explanation with some of the examples of based on the laws of exponent. Till then, thank you class.